Hello, my dear students. Welcome to my YouTube channel, That's Concepts of Chemistry. Before starting today's lecture, please do subscribe this channel and press the bell icon to get the regular updates of the upcoming lectures. My dear students, in the previous lecture, we have found the stability order of O2 molecule with 1 unit positive charge, O2 molecule and the O2 molecule with 1 unit negative charge by evaluating their bond orders. Today we are going to find the stability order of N2 molecule, N2 molecule with 1 unit positive charge and N2 molecule with a 1 unit negative charge, again by evaluating their bond orders. So let's move to the screen. So I have already made the molecular orbitals for the nitrogen molecule. In the case of nitrogen, you can easily observe one exception, and that exception is the energy of pi 2px pi 2py molecular orbitals is lesser than that of the sigma 2pz. In the previous lecture, we have talked about the oxygen molecule, and in case of oxygen, the energy of sigma 2pz was lower than that of the pi 2px pi 2py. But from atomic number 1 to atomic number 7, the energy of pi 2px pi 2py will be lower than that of the sigma 2pz. So now let's move to the today's topic. Firstly, I am going to evaluate the bond order for nitrogen molecule, that's N2 molecule. So I am marking my one nitrogen on the left hand side and the another on the right hand side. So what's the atomic number of nitrogen? That's 7. So its configuration will be 1s2, 2s2, 2p3. So now let's fill these 7 electrons on the left hand side, that's 1s2, 2s2 and 2p3. So I'm filling my first electron over here in the 1s, that 1s2. Now that's a turn of 2s, now it's 2s2. Now it's turn of 2p and that's 2p3 according to the Hund's rule, the first electron, second electron and the third electron. So we got total of 7 electrons on the left hand side for the first nitrogen. Now let's move to the second nitrogen, which is on the right hand side. Again we have to fill the same configuration of 1s2, 2s2, 2p3. So we got the 1s2, that's the 2s2 and that's again 2p3 according to the Hund's rule. So in center we have to fill the molecular orbitals for the N2 molecule. Now in N2 molecule we are having total of 14 electrons, the 7 electrons from the nitrogen on the left hand side and the 7 electrons from the nitrogen on the right hand side. So we are having total of 14 electrons. So I am going to fill these 14 electrons in molecular orbitals according to the Aufbau principle and the Hund's rule. So now I am filling the 14 electrons in the center. That's the first electron in sigma 1s and the second electron in sigma 1s. Then the third electron in sigma star 1s and the fourth electron in the sigma star 1s. Now fifth electron in sigma 2s, sixth electron in sigma 2s again. Now seventh electron in sigma star 2s and the eighth electron in sigma star 2s. Now the ninth electron in pi 2px and the 10th electron in pi 2py according to the Hund's rule. Then 11th electron in pi 2px and then 12th electron in pi 2py and then 13th electron in sigma 2pz and the 14th electron in the sigma 2pz. So we got the total of 14 electrons in the molecular orbitals. So let's find the bond order for the N2 molecule now. So I am writing bond order for N2 molecule. What's the formula of bond order? That's the number of bonding electrons minus number of anti-bonding electrons divided by 2. So let's firstly count the number of bonding electrons. I am marking first of all number of bonding electrons, that is the number of electrons that are present in bonding molecular orbitals. Who are the bonding molecular orbitals over here? The molecular orbitals which are not having the star sign over them, that is sigma 1s, sigma 2s, pi 2px, pi 2py and the sigma 2pz. And again saying our bonding molecular orbitals are sigma 1s, sigma 2s, pi 2px, pi 2py and the sigma 2pz. So let's count the electrons present in the bonding molecular orbitals. We got the 2 electrons in sigma 1s, 2 in sigma 2s, we got 4, then 4 in pi 2px, pi 2py we got the 8, and then 2 in sigma 2pz we got the 10. So we got total of 10 electrons. That again I am writing the 2 in sigma 1s, 2 in sigma 2s, 4 in pi 2px, pi 2py and 2 in sigma 2pz. So we got total of 10 electrons in bonding molecular orbitals. So I am marking we got total of 10 electrons in bonding molecular orbitals. So we can say we are having 10 bonding electrons. Now let's count the number of anti-bonding electrons. Number of anti-bonding electrons. So first of all, here anti-bonding molecular orbitals are those which are having star sign over them. I'm deleting some things to make you better clear of it. So now I'm marking anti-bonding molecular orbitals, that is the molecular orbitals having star sign over it. We got the sigma star 1s, we got the sigma star 2s. Right now only these two anti-bonding molecular orbitals are having electrons. Now here we are having 2 electrons in sigma star 1s and 2 electrons in sigma star 2s. So we got total of 4 electrons in anti-bonding molecular orbitals. So I am writing we got the 4 electrons in anti-bonding molecular orbitals. So now let's evaluate its bond order. My bond order for N2 molecule comes out to be number of bonding electron 10s minus number of anti-bonding electron 4 divided by 2. We got it to be 3. So that means bond order for N2 molecule is 3, that is N and N are having 3 bonds between them. Now let's talk about the bond order for N2 molecule with a unit positive charge. Now I am marking bond order for N2 molecule with 1 unit positive charge. So first of all, in N2 we were having total of 14 electrons that we have filled in the molecular orbitals. Now we have to again refill these molecular orbitals. I am deleting the old electrons first. Now it's the turn of N2 with the 1 unit positive charge. With a 1 unit positive charge. That means N2 molecule has lost 1 electron. So now this time we have to fill 13 electrons, not the 14. So we have to fill 13 electrons this time. We have to fill 13 electrons. So let's fill the 13 electrons now. We got the 2 electrons in sigma 1s, 2 electrons in sigma star 1s. then 2 electrons in sigma 2s, then 2 electrons in sigma star 2s. Up to here we have filled total of 8 electrons. Now ninth electron in pi 2px, 10th electron in pi 2py, 11th electron in pi 2px, 12th electron in pi 2py, and then 13th electron in sigma 2pz. So here we have filled 13 electrons for N2 molecule with the 1 unit positive charge. Now again let's count the number of bonding electrons. I'm writing number of bonding electrons, that is electrons that are present in bonding molecular orbitals. So again, as a revision, I am marking the bonding molecular orbitals, that is the orbitals which are not having star sign over it. So we got my first bonding molecular orbital to be sigma 1s, then it's sigma 2s, then it's pi 2px, pi 2py, and then it's sigma 2pz. So I have marked the bonding molecular orbitals. So now let's count their electrons. We got the 2 electrons in sigma 1s, we got 2 electrons in sigma 2s, we got the 4 electrons in pi 2px, pi 2py, and we got the 1 electron in sigma 2pz. So that means we got total of 9 electrons. We got total of 9 electrons in bonding molecular orbitals. So I'm writing we got the 9 electrons in bonding molecular orbitals. So now let's count the number of anti-bonding electrons, that is electrons that are present in anti-bonding molecular orbitals. So let me delete something for you first to make you understand better. So now I am marking the anti-bonding molecular orbitals, that is the molecular orbitals having star sign over them. So that's firstly sigma star 1s, and we got the sigma star 2s. So we got the two anti-bonding molecular orbitals which are having electrons. So that means we are having 2 electrons in sigma star 1s and 2 electrons in sigma star 2s. So we got total of 4 electrons in anti-bonding molecular orbitals. We got the 4 electrons in anti-bonding molecular orbitals. So let's evaluate their bond order. Number of bonding electrons now 9. Number of anti-bonding electrons now 4. Divide by 2, we got it to be 2.5. So now let's move to the next point. We have to evaluate the bond order for N2 molecule with a 1 unit negative charge. Now bond order for N2 molecule with 1 unit negative charge. Here let us firstly delete the previous electrons to have a fresh start for the N2 negative. Now firstly, in case of N2 molecule, the very first case, we have filled total of 14 electrons, the 7 from first nitrogen, 7 from the another nitrogen. We have filled total of 14 electrons. Now this time we have to take the example of N2 molecule with the 1 unit negative charge. So that means we have to increase 1 electron in N2 molecule. Now in this case it will be now 15 instead of 14. So it will be 15 electrons instead of 14. So now we have to fill 15 electrons. So I'm starting filling the molecular orbitals according to the Aufbau principle and the Hund's rule. Now, the first two electrons in sigma 1s, next two in sigma star 1s, next two in sigma 2s, next two in sigma star 2s. Up to here we got the 8 electrons. Now, ninth electron in pi 2px, 10th electron in pi 2py, 11th electron in pi 2px, 12th electron in pi 2py, 13th electron in sigma 2pz, 14th electron in sigma 2pz, and the very last 15th electron in pi star 2px. So we got the 15 electrons in the molecular orbitals of N2 molecule with a 1 unit negative charge. So let's count the number of bonding electrons. Number of bonding electrons, that is electrons that are present in bonding molecular orbitals. For that, let's mark the firstly bonding molecular orbitals. We got the sigma 1s to be the bonding molecular orbital, sigma 2s to be the bonding molecular orbital, pi 2px and pi 2py to be the bonding molecular orbitals, and the sigma 2pz to be the bonding molecular orbital. So let's count the number of electrons present in them. We got the 2 electrons in sigma 1s. I'm counting it again. We got the 2 electrons in sigma 1s. Then we got the 2 electrons in sigma 2s. Then we got the 4 electrons in pi 2px and the pi 2py, and the 2 electrons in sigma 2pz. So we got total of 10 electrons in bonding molecular orbitals. That's 2 plus 2 4 plus 4 8 and 2 10. We got the 10 electrons in bonding molecular orbitals. Now let's count the number of anti-bonding electrons, that is electrons that are present in anti-bonding molecular orbitals. For that, let me delete the previous countings. Here, firstly, we have to mark the anti-bonding molecular orbitals. We got the sigma star 1s, the anti-bonding molecular orbital, sigma star 2s, and the pi 2px, pi 2py. We got the anti-bonding molecular orbitals with the star sign over it, and we have marked that are having electrons. So now let's count the number of electrons that are present in anti-bonding molecular orbitals. We got the 2 electrons in sigma star 1s, we got the 2 electrons in sigma star 2s, and we got the 1 electron in pi star 2px. So we got total of 5 electrons, 2 plus 2 plus 1 5, 5 electrons in anti-bonding molecular orbitals. So I'm writing we got the 5 electrons in anti-bonding molecular orbitals. So what's bond order now? Its bond order will be number of bonding electrons 10, number of anti-bonding electrons 5, divided by 2, we got it to be 2.5. So we got the bond order of N2 negative to be the 2.5. For N2 positive we got 2.5. For N2 we got the 3. I have already told you, higher the bond order, higher will be the stability of that molecule. So that means N2 molecule will be the most stable. Then N2 positive, whose stability will be equal to that of the N2 with a negative charge. That's all for today's lecture. We have evaluated the bond order of N2 to be 3, and for N2 1 unit positive charge and N2 with a 1 unit negative charge, we got the bond order of 2.5. That means the stability of N2 will be the maximum and that of the N2 with a 1 unit positive charge and that of N2 with 1 unit negative charge will be equal but less than the N2 molecule. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.